Greetings, everyone. I'm Patrick Veazie with NC State University, and today we're going to be taking a deeper dive into Gerber production and crop management. So, to kind of start off with what we'll be covering today, we're going to be looking at Gerbera. It's a very popular crop, especially here in the Southeast. It can be easily grown with the proper management. So, today we'll be taking a deeper dive into the cultural management, such as dialing in that fertilizer rate, your pH, and your EC. Then some diagnostics of the most common problems that we've seen over the last spring. So for cultural management, one of the big things is making sure that shoot tip is not buried, and we'll dive into a little bit more of the common problems with that later. But for optimal temperatures, looking at between 71 and 77, in nighttime of 53 to 61, and ensuring that that relative humidity is below 80% once it begins to flower to prevent botrytis problems from exploding. A lot of these recommendations can be found in the Ball Red Book as well for more information. So your initial plug quality is going to be indicative of your final product. If you have poor quality going in, you're going to see poor plant quality coming out. So these plants shown here were spread out throughout the bench. And essentially what happened is they were either tugged out of that plug just a little bit too tough and the roots broke off, causing them to lag behind the others, or they were just small plugs going in. When they're being scattered in amongst all the other crops, they were starting to become overwatered, which then resulted in poor final quality. So segregating out those poor plugs and handling them differently compared to just mixing them in, you're going to lose them in terms of quality amongst all the others. So dialing in your pH and EC, your optimal range is going to be roughly 5.8 to 6.2, but Gerber will both see low and high pH problems. Shown here on the left is a pH of 4.7, where those lower leaves are seeing micronutrient accumulation occurring and manganese blackening. Shown here on the right is pH of 6.8. Where that pH gets too high, you start to see that intraveinal chlorosis of the upper foliage and iron deficiency occurring. So your EC ranges are shown here for your 1 to 2 extractions, your SME and your pour through. The pour through for in-house monitoring of roughly 2 to 3 is kind of what we're targeting. And here at NC State University, we ran an in-rate study using 17,517 fertilizer. So it's neutral. And we can see that at 37.5 part per million, the plants were very stunted in a much lighter green compared to the others. And at 600, we saw high ECs burn occurring on the foliage. So where can you maximize? Roughly 112 to 150, seeing that larger growth up to 225. But what we look at here in terms of pH and EC using a pour through, we can see that the pH begins to drop once you get greater than 112. So that plant is no longer actively uptaking all the nutrients that it's given, and accumulation starts to occur. And we're starting to notice that with EC as well. Once you go above 150 part per million, that EC shoots up above what we would recommend. And then plant dry weight is maximized around 112 part per million. So in that 112 to 175 range is kind of what we'd recommend for a fertility rate for Gerbera to keep you within that recommended pH and EC range. So troubleshooting disorders, looking at the most common ones that we've seen this year so far. Calcium and boron are kind of what we see a lot is where that it's a rosette, so that growing tip gets buried within the substrate and covered up, which reduces the transpiration. Calcium deficiency, you see that leaf tip burnt or leaf tip curling and not fully expanding due to lack of transpiration. And boron, you get those thicker leaves developing as well. So iron deficiency, common causes are overwatering or high pH. So here were some plants that we picked up from a local grower. And we can see that they're highly chlorotic once we initially picked them up, and they were being overwatered, scattered in amongst the plants. And then we took them out and only watered them as needed for 2 weeks. And then you can see that they greened up and grew out of that deficiency for that new growth. And then low or high EC, low EC, you start to see that stunting and the pale green coloration of the foliage and lower leaf yellowing. And then high EC, you see that stunted plant growth once again. with high EC burn on that lower foliage, starting along the leaf margin, then spreading inward to the center of the plant. Western flower thrips are a large problem with Gerbera. Almost it seems to attract them more than a lot of other crops in the greenhouse. And you start to see that bad leaf formation occurring where they'll feed on the leaves, and then as it tries to expand, you see necrosis forming as well. And they also will feed on the flowers, leading to poor bloom quality. So controlling your thrip population is very important for Gerber production. And then the thrips will also spread viruses. INSV and Spanish spotted wilt virus can both be spread by thrips. And you see this pale brown and necrotic spotting occurring around that feeding damage. So controlling your thrips is very essential. And discarding all of the plants that are impacted to prevent virus spread. Up next, we have botrytis. This is common when water sits on the rosette or on the foliage, and maintaining a lower relative humidity can limit the occurrence. Sclerotinia is one of the more common diseases we've seen with Gerbera this year. It's this white fungal mass that's occurring, and you'll see the sclerotia formed shown here. And the plant will essentially melt down, where it's got plenty of water, but it's almost exhibiting drought-like symptoms. One of the things that to prevent this are irrigating less, warmer temperatures, and potentially fungicides as well. So kind of the take-home message and how for culture is irrigating with a fertilizer solution less than 200 part per million, constant feed to promote plant growth while maintaining that optimal substrate pH. Be careful not to overwater due to iron deficiency and potential botrytis, and then controlling your thrips population to prevent leaf distortion, as well as limiting the spread of potential viruses. With that, I'd like to thank everyone for attending today.